walking a tightrope with the Raspberry Pi. Now, this is our research project, and I'd like to introduce our group: Andrea Amanza, Andrew Martinez, Garrett Henchis, and myself, Demetrius Portillo. What is a Raspberry Pi? A Raspberry Pi is a small, basic computer. Similar to what we have in cell phones today, with a combined CPU and GPU. It's used to teach computer science. Comes in different models throughout the years. We used a Raspberry Pi 3 for this particular project. It can be paired with many peripherals to increase functionality of the Raspberry Pi. What are we using it for? Well, we use a Raspberry Pi to create a game in which you try to move along a tightrope and reach a destination. We will achieve this with coding in Python by using a device called a Sensehat, starting from the blue LED and walking to the green LED, as you can see in the example to the left. Now, what is a Sensehat? A Sensehat is an add-on for the Raspberry Pi, one of the peripherals mentioned previously. It comes with the following: an 8x8 display of programmable LEDs, a joystick, a gyroscope sensor that can detect roll, pitch, and yaw, of which roll and pitch are the most important for this project, an accelerometer that can measure acceleration force, a magnetometer that can measure strength of a magnetic field, a humidity sensor that measures the amount of water vapor in the air, a barometric pressure sensor that can measure air pressure, a temperature sensor that measures temperature in the surrounding area. Keep in mind that it also detects heat coming off the Sensehat. Next is the Python code. To start the code, we had to import the Sensehat to collect the necessary data by using from sent_hat import Sensehat. We then define the colors of the LEDs using X and Y variables as a path and background, as well as using another variable to define the color of the character. We use B for blue. Next is setting the character's starter position using variables character X and character Y. We set these variables to 0. After this, defining the path is required, utilizing the same X, Y variables. With definitions created, setting the path and character is next, and this is done by setting sense.setPixels to display the image of the path on the LED board. To collect the pitch and a roll, we use sense.getOrientation. Since these are now defined, next up is creating if statements for character movements. Continuing the code using an if statement to determine the character has gone off path. And lastly, getting the character back to the starting position. Here we have an example of the game. Now watch as the character moves depending on how the Sensehat is tilted. As we saw, this example of the game was fairly easy, and it can be made to create a more difficult path, or even changing the response delay with our sleek code. It can make the game even more difficult. However, there were problems faced during this research project. One limitation of the Sensehat when used with the Raspberry Pi Linux is that the Linux frame buffer bit shifts 8-bit numbers. This changes the RGB codes so they may be different when getting them after setting them. Another error we ran into is the speed and response time of the gyroscope. Sometimes the Sensehat will be rotated back to parallel with the ground, but the values being reported to the simulation were older values before being rotated back to parallel. This would cause the character to roll off the tightrope unintentionally. Our conclusion is that a Raspberry Pi is a beginner-friendly gateway into the world of computer science, as we have learned how to a basic understanding of Python coding. With the use of external components, the Raspberry Pi can be expanded to have many more functions. With the use of a Sensehat and coding in Python, we were able to mimic a tightrope walk by controlling a character's movement via rotating the Sensehat.